In this video, we're going to talk about measures of dispersion, particularly the standard deviation. Let's do it. A common measure of dispersion is the range. You might remember that this is the maximum subtracted by the minimum. This number gives us the distance from the minimum point to the maximum point. It is a measure of dispersion because the logic is that the bigger the distance from the smallest point to the biggest point, then the more spread the data is going to have. Let's look at an example of that. On this data, you can see that as the range increases, the spread also increases. But is that always going to be the case? Not necessarily. Let's look at this second data set, which has the same minimum, the same maximum, but the data members are a little bit different. The range for both of them is the same. In this new data set, you can see that there is much less spread because most of the data is accumulated in one region. While in the original data set, the data is more spread out throughout the number line. So that's why the range is not always the best measure of dispersion. Ideally, we want a number that will give us a bigger result when the spread is bigger. One idea is to measure the distance from each point to the mean. So on these number lines, we're going to put the mean for each data set in red. And now let's take a look at the distances from each point to the mean. We can see that the distances in the second example are a lot smaller than the distances in the original example. So if we take the average distance from the data set to the mean, the original one is going to have a bigger average distance. So this is a new idea for calculating the spread of the data. However, this does not quite solve our problem. Let's take a look at this example. We have -5, 0, and 5 as a data set, and a different data set which is 0, 0, 0. The mean for both of these data sets is 0. Let's calculate the mean distance from the data set to the mean. We can see that in this case, the distance from -5 to 0 cancels with the distance from 0 to 5. So the average distance comes up to be the same, which is not what we want, because clearly the data set with the -5, the 0, and the 5 has more spread than the data set with just the 3 zeros. To remedy this, we're going to not just take the distance from the data set to the mean, we're going to actually raise it to the power of 2 so that the distances don't cancel and they're always adding. When we do that, we can see that we get a bigger result for the data set that has more spread. So this new idea is what is known as the standard deviation. So to calculate the standard deviation, all you need is to add the squares of the distances from each data member to the mean, and then divide it by the total number of data points. To compensate for raising it to the power of 2, after we have done the calculation, we're going to take the square root, and the final result is our standard deviation. Alright, that's it for this video. See you next time.